Should be seeing my screen.
See it?
And we'll get started with this one, okay?
Yep.
So represent the other two numbers in terms of x. Okay, so x is one number, and then the second number is 45 minus x. Did you get that?
Oh, all right. So it's x 45 minus x. So the sum of two numbers is 45. Determine the function p that represents the product of two numbers.
Right, but did you get for a x and 45 minus x? Because that leads to b, and then.
Oh,
C.
okay. So represent the other two numbers in terms of x. I did not get those.
Okay, so the way you start a, I'll just start it down here, is you would say, okay, x is one of the numbers, and maybe y is the other number, and that's 45. If you solve for y, you get y equals 45 minus x, and that's why it's the second number.
Oh, I see.
Okay, so the restrictions here is that x has to be greater than 0, because it says that they're both positive, and then 45 minus x has to also be greater than 0.
Okay, that's fair.
Part C, the product of two numbers. What math operation is that?
The product of two numbers, multiplication,
yeah, multiplication. Right? So we have x times quantity 45 minus x.
Oh, okay. 45
and
minus
that's your p. I mean, it could come, the p could come first, but that's, that's essentially p. All right, for part D, you want to set this product equal to 504.
Oh. So x 45 minus x equals 504. And then we determine analytically. Does that mean that we just solve it?
Yeah, in this case, you're probably gonna factor well, you're gonna distribute this x in here, so you're gonna have 45x minus x squared equals 504. I'm gonna move everything to the right, so you get x squared minus 45x plus 504 equals 0.
Wait, wouldn't it be a negative x squared though? Oh wait, no, you're moving it to the side. I see.
Yeah.
All right.
And then this you can factor, I guess. I actually don't. I mean, I don't know that right off the top of my head. So I'm gonna check it out here with Wolfram. You can graph this. You can use a quadratic formula, but you're basically trying to figure out the two numbers that get you to 504. And we'll see if I can just come up with those quickly here. Okay, so 21 and 24.
Mm-hmm. All right.
So that means that x can be 21 or x can be 24. And
right.
this is the final answer. So let's just say you choose x to be 21. You know that y is 45 minus 21, which is 24. And let's say you're like, oh, well, I really wanted x to be 24. Well, y is 45 minus 24, which is 21.
Makes sense. All right. Let's go on to number 13 for maximizing area.
Okay. I will get back to that and pull it up here. So number 13, maximizing area. All right, I'm going to snip that and drop it into our workspace. Let's see here, we can go all the way up. And let's get this pasted in, make it so that everyone can read it. Farmer has, oops, that one's not very visible. Farmer has 1,000 feet of fence to enclose a rectangular area. What dimensions of the rectangle result in the maximum area enclosed by the fence? Okay, so good to draw a picture here, rectangle. And the 1,000 feet it's the perimeter. It's going all the way around. So I'm going to call this x and this y, this x and this y. The perimeter is 1,000, but the perimeter is also 2x plus 2y.
Yeah, and you can set those equal to each other.
You can set 1,000 equal to x equal to 2x plus 2y. Divide everything by 2, so you get 500 equals x plus y. Now, that's not what it's asking for. It's asking for the maximum area. So the area of this thing is xy. Okay, but you want to get everything in terms of x. So if you solve this for y, solve for y over here, you get y equals 500 minus x. That goes into this formula over here, x times 500 minus x, like that.
So you get 500x minus x squared.
Now, one of the things that I know and is that your graph of this, and this is what you have to be able to realize, is that the graph has a 0 here at 0 and then at 500.
Yeah.
And a parabola always has a maximum or a minimum halfway between those 2 points. Now, you could also use the formula for minus b over 2a for the vertex.
Yeah.
But it's always halfway between. So if we do that here, it's minus 500 over 2 times minus 1, which is 250, which is what I just said. It's halfway between. That's the x value.
Oh, okay.
Okay, so whenever you're dealing with a parabola, the min or max is always halfway between. To find y, we take this and go back up here. Y is equal to 500 minus 250. Y is equal to 250.
Oh, for x. All right, so x equals 250 feet. Is that feet? Yeah, all right, feet. And
So
we
they're
got,
both 250. So the area, which is what you're trying to find, is x times y. It's 250 times 250, which is like 62,500 feet squared.
all right. Let's go to number 14.
Okay. Snip it and put that into our workspace.
A homeowner has 80 feet of fence to enclose a rectangular garden, so we know that that's the perimeter. So we can already go 80 equals, what is it? Dimensions to the rectangle. Result would be x plus y. 2x plus y. Plus
2x
2y.
plus 2y.
Yeah. And so we can find the area, which is xy. A equals x times.
So this is another situation where the parabola has a 0 at 0 and at 40, and that midpoint, that height is at 20.
All right. That makes sense.
If you feel more comfortable using formulas, you can just to confirm it, but it's always true. There's no exceptions to it.
Yeah, of course. So we got that x, which would be 40. So then we got 40. Oh, wait, no. 20 times 20, which is 40. We have 40 for y. So, no. That's not right. So, yeah, I see.
The
Never mind. I'm
parabola is
making.
maximized right at the middle there, and the x value is 20. The y value is 20. Y doesn't refer to this, though. This is actually a of x on this y-axis here. And there's a bit of confusion with that. But the area is x times y, or 20 times 20, which is 400 feet squared.
Y equals 20. That equals 400 feet square. Perfect. Next, get a number 17.
Okay.
Hitting a baseball.
All right. I'm going to snip this into our workspace here. They give you a function here, and when they ask you for the height of the baseball after 1 second,
Mm-hmm.
that's pretty straightforward because you're going to just put the value of 1, t equals 1, into the function. So it's
Yeah.
s of 1 minus 16, 1 squared, plus 44 times 1 plus 4.
So we got negative 16 plus 44 plus 44 plus 4. So 48. That'll end up being 32.
32. And then here, they're pretty picky about units, so
To be like 32 feet.
yeah, although they actually don't tell you the height. They should have said height in, oh, there it is, in feet. There it is. Okay. Yep. Now, find the maximum height of the baseball. So whenever it says the maximum or minimum or whatever, you're going to think vertex.
Yeah.
You need to find the vertex. The vertex
Oh, okay.
is always at minus b over 2a. In this problem, b is 44 and a is
16 times 2. Negative 16 times 2.
Yeah, now this one doesn't work out as nicely. And just to be clear, though, this is the time where it happens. There's two things that they could ask for. The first is like, when does it happen, and that's what this is. And then the what is the height is when you put that number back into the function. So you have to get this value out, this minus 44 over minus 32.
2.75 seconds. 2.75.
2.75. So now to carry this out here, you have to put in 2.75 into the
Beginning.
the function itself.
Oh, okay.
Because you know when it happens, but you need to know what it is. What it is. So there's two things they're always asking for.
What does that 2.75 represent? So
The
it
time,
represents
the time, the x value. It's the x value
okay.
where it reaches its maximum height.
Okay. And the S of t is just 2.75, right? And
No, the t is 2.75. The s of t is the value that you're putting that 2.75 back in
oh, I see.
to get the value out.
Okay. And so now I'm gonna square this up and multiply that by negative 16. And it's negative 121 plus 44 times 2.75 plus 4. I got 4 for this.
For the height,
Yes, 4 feet.
it's got to be higher than that because so I think actually the issue is right here. This is not the right number. Or 2.75 is not the right number. When you put that into your calculator, you want to make sure that you
An even number?
so I got 11 over 8, which is 1.375. Yeah, so this is 1.375.
Wait, what?
And
So 44 divided by 32?
yeah,
Oh, okay.
so that changes this line down here.
Yeah, that completely changes everything, yeah.
S of 1.375, t is now 1.375 minus 16, 1.375 squared plus 44 times 1.375 plus 4.
All right. got this number squared up times negative 16, negative 30, 30.25 plus 4 times 3.5. So I got 34.25 feet.
That's reasonable. It's got to be bigger than the other answer.
Yeah, a lot bigger.
So the key to this problem is to understand when it asks for the maximum, you're not finding that intermediate answer. You're finding because they could ask you there could be another, like there could be an A/B here that asks you when does it reach a maximum height? When does it reach a max? And that's the t value.
Mm-hmm. All right, on to number 18 after hitting a golf ball.
Okay, let me snip that in here. You said 18. Ooh. Okay.
Is it just going to be 0 for initial height?
Let me get it snipped in because it's I got another screen and it's too small to when I look at it until I enlarge it. Okay, what is the initial height of the ball? It's whatever the function tells you at t equals 0. So your answer is yes. The answer to your question is yes. When t equals 0, h of 0 equals minus 16 times 0 squared plus 60 times 0, which is 0. How about part B?
We just kind of plug it in for
Exactly.
1.5.
Yep.
Or 1.5 squared. And multiply that by negative 16. And I got negative 36 for that. And then we add that to, what is this? 1.5 times 60. So 90 plus negative 36, 54.
54. And then how about units here? It's got to be,
This says 54 feet.
yeah.
All right, now we got to find the maximum height of that golf ball. So we'll find that vertex.
Yep. That's great. You're finding the vertex. Good word choice here. It's minus b over 2a minus 60 over 2 times minus 16. So I get 1.875 seconds.
I got that too.
So that's half credit because you've got to then take that number and put it back into the function h of 1.875.
All right. This says negative 16. 1.875 squared times negative 16. All right, vertex will be 56.25 feet.
Great.
75, 16.75. All right, so this would be 56.25 feet. All right, on to number 20.
Okay. Still on. So the cylindrical aluminum can, is that the right one?
Yep, that is correct.
All right. Sorry, I'm having an issue snipping. It's coming shortly. So a cylindrical can is being constructed to have a height of 4 inches. Okay, volume of 28. So they're reminding you of the formula in this problem here. I'm about to shares. You can see it here. So they're telling you the volume. They're giving you the volume. They're also giving you the height. Guess I'm not sure. Is there more to this? Is there a part? No. There's no question.
Wait, what? What is this talking about?
Okay. Approximate its radius. Okay. The volume is okay. So there's 1, 2, 3 unknowns, but they give you the height of 4, the volume of 28. So you got 28 equals pi times 4 squared times h. And they just, when it says approximate its radius, it wants you to solve for r, and then use a calculator if you need to. So this is 28 equals 16 pi times h. And then you're solving for, I'm sorry, I've got this backwards. This is not right.
It's just going to be 28 divided by 16 pi.
Pi r squared times, well, it's the height is 4 though. I put in the incorrect number. So it's 4 pi r squared. The height is 4. I put it in for r for some reason, which is not correct. And then you're solving for r.
Okay.
So you're dividing both sides by 4 pi. That reduces to 7 over pi equals r squared. And then you're going to take a square root of both sides. So you get the square root of 7 over pi equals the square root of r squared. R equals the square root of 7 over pi. It says approximate. That might mean, hey, go ahead and grab a calculator and see if let's see if you can get that number.
So we got 7 divided by pi. All right. 7 divided by pi. 1.49.
What about units on that?
Pi equals r equals 1.49, and this would be inches.
Yes.
All right. Last problem for the homework will be 41B.
The Americans over 100 feet of age, 100 years of age. Is that right?
Yes.
Okay. You said just part B.
Yes.
Okay. The reason is that's the only one that you're probably able to do. They want you to construct an equation from this data set here. Problem is the problem is it's a little bit distracting because there's only a few things that you only have a few pieces of information here. So the quadratic function f of x is, they're telling you, it's h squared plus k, but they tell you the 2 points that they want you to use.
Yeah.
Like they tell you use this as x and this as y, and the y is really f of x. So they're saying use a 50 for f of x, a 4 minus h squared. Oh, as the vertex. I apologize. I didn't read that. That means that the vertex is h comma k. That means that h is 4 and h is 50.
All right, so x minus 4 squared plus 50.
Yeah,
is that what that is?
So we can get it down to this first. X minus 4 squared plus 50. And then this other point becomes 110 equals a, 14 minus 4 squared plus 50, and you're going to solve for a. So you're using that other point as an xy.
So solve for a. Okay.
Solve for a.
So you got 100 plus 50, which equals 160a. A equals 110. Then we divide on both sides. 160. And so it just becomes 11 divided by 16, and that's just like some random decimal. So I could just leave as 11.
I've got it as something a little nicer here. I mean, it's 14 minus 4 squared is 10. 10 squared is 100. When you subtract that 50, you get 60. I mean, I got
I see.
0.6 here.
Oh, okay, I see. I did that wrong. Let me correct that. All right, so minus 50 on both sides. That's 70. 70 equals, what is that? 100A. Oh, you're right, 60. 60 equals 100A. So then it becomes f of x equals 0.6 x minus 4 squared plus 60. All right. All right, so that's the homework that I wanted to finish. There's you mind if I send you the pages of another homework?
Yeah. I'll just it would be best. You did send quite a few pages, so maybe you've already sent it. No, just no.
This one's from a previous lesson. Let me
Okay.
get it out.
Yeah. So if you could send to the learning@mathbymatthew.com, that would be
Preferred.
preferred. So cut down a little time here.
All right. Here we go. I'll send it to you. Take a picture of these. This is an attachment. And I'll send you a picture of this. There we go. And it should send any moment.
All right. Let's take a look. Looks like I got nothing yet. All right, there it is. Okay, which question would you like to start with, or where do you want us to go?
Can we start off at number 45?
Absolutely. So 45, solve each equation, real solutions. Okay. So I can actually just write these in. They're not all that sophisticated to get in here. They're just a couple lines here. So 45 says 4x squared minus 12x equals negative 11. Is that what you're looking at?
There is.
Okay, so first thing I'm going to do is move that 11 to the other side. And when you're solving quadratics, you almost always want to have everything on one side of the equation. Now, this leading thing here is not a 1.
Okay.
If it was a 1, you would just try to find two numbers that multiply to 11 but add up to negative 12. Because it's not a 1, you do something different. You would try to do a GCF, greatest common factor, but there is none because 4 doesn't go into any of the other ones. So the technique is to multiply the 4 and the 11 to get 44. And then you're trying to find factors of that add up to negative 12. So for example, 1 and 44, 2 and 22, 4 and 11. I think that's it. So none of these add up to that. Would you agree?
Yeah, so he's the quadratic formula.
Yeah, and
I
that's
set
kind of
that up. So I got 12 plus or minus square root of 144 minus, so 44 times 11. That would be 484, then over 2 times 4.
the second number here. It's 4 times a times c. It's 4 times 4. This 176 is 4 times 4 times 11.
Mm-hmm.
Is that? I heard a
Wait,
different
no.
number.
4 times 4 times 11.
Yeah.
Oh, no, you're right. 176.
Okay.
Operator error on my part.
Yeah. So you got 12 plus or minus the square root of negative 32 over 8. And as the class you're in, complex results are okay. So you're going to get an I in your answer.
So you can get 12 plus or minus I root 32 over 8, but I can also simplify that root 32 into 8 times 4, so it can be 2 times 2, which is 4 root of 2.
It's
Simplify
it's 4 root 2, so it's 12 plus or minus 4 root 2, and then there's an I. We'll throw in over 8, and then you divide each of these by 8.
Oh, okay. So we get 12 over 8 plus or minus 1 half, 1 half, 1 half I root 2.
Yes.
And I can simplify 12 by 8, simplify fraction. It'll be just 3 over 2. All right. Next, I want to go to number 47. This one I had a lot of difficulty with.
Is it 47?
Mm-hmm.
All right. Okay. I think you and I were the ones that were talking about this. The solution to this problem is the same as the solution to one which is a multiple of this. So you can multiply everything in here by a number that gets rid of the fraction.
Oh, I can?
Yes, like 12.
Oh, 12 works perfectly. I
Now
didn't
you
think
don't
about that.
have to do this, but
It
you
works more
it's
effectively, though.
it's better. Yeah, it's so this becomes 4x squared plus 3x minus 36.
Equals 0. And I can
And
use quadratic formula and simplify it out, right?
you can, I mean, I would at least try to multiply the numbers. If it's not, if you think all these are quadratic formula, then I guess you can just start with that. But I mean, that's like the last thing I would try.
I can try to go for the older formula that I got. So 36 times 4 is 144.
It's
And
negative though, so negative
yeah,
144. Now you're looking for something that's 3 apart. That's where it gets a little dicey because, like, obviously 12 and 12 works. One's negative, one's positive. Like 9 and 16 work, but they're more than 3 apart.
yeah, so it has to be the quadratic formula for this again. So you got negative
Yes, it
3
does.
plus or minus root of, what is it, negative b squared, what should be 9 minus 4 times negative 36. So the inside will add, and then 2 times 4, which is 8. All right, so 4 times 36, 596 plus 9. So now I got negative 3 plus or minus root 585 over 8. So let's see if we can simplify this out, and you really can't, so you just leave it alone.
Um, that 585 might reduce.
Oh, it can? Oh,
Well, I'm looking at it here. 117. No, 117 is prime. No, it looks like that's it. Um, that's it's a rough
it's an
one.
odd question, isn't it? With the oddball.
I'm gonna just check this because I just feel like we probably should have gotten something a little nicer, but maybe that's the way this one was designed. Um,
I think these are, this lesson is supposed to be like really
the
like
the
not very nice
585 the
numbers.
585 does reduce. So 585, it's actually a multiple of 3
It
because
is? All
5
right.
plus 8 plus 5 adds up to 18, which is a multiple of 3. Um, the then you get to the guessing game here. Like 3 times 200 is 15 too big. So it's
But you can turn it to 3 root 65, though.
yes, that's where I was going. So it becomes negative 3 plus or minus 3 root 65, each of them over 8.
Okay, that's fair.
I wouldn't argue it's that much better than what you had, but it is
An
reduced.
improvement, yeah.
Yeah.
Uh, All right, let's go over to number 49 here. All right, so this turns into x squared minus 6x, and then plus 9, I think, right? No, that doesn't work out.
Are we? Are you asking me to go through 49 or something else?
49, please.
Okay, so 49 is the type of problem you would actually see before any of these other ones because it uses the square root property. All the other ones we had to get x by itself, or all the terms on one side. Here, the quantity 3 minus x has been isolated, so you want to undo the root first. So you take a square root of both sides.
Oh.
Plus or minus the square root of 25. You only do that because the 3 minus x has already been isolated.
Oh, okay. So we can do, I see. 3 minus x equals 5.
Plus or minus 5.
Oh, plus or minus 5. I keep forgetting that it's plus or minus. All right, plus or minus 5. And now we can just kind of solve
So this is where the way this is written is kind of like, it's kind of a little like oh, what do I do? You can actually add x to both sides. So you
Oh,
get
I can.
3 equals plus or minus 5 plus x. And then it really becomes two things. It's 3 minus 5, 3 plus 5.
Oh. And then you get just x equals negative 2 or just 8. Correct?
So there's two answers, negative 2 and 8.
Perfect. That's what I got. All right. On to number 50. And we can do the same way of working it out. I'll square root both sides. So now I got 2 plus x equals plus or minus 7. I'll do the same for the last part, minus x. Well, actually, that doesn't really work out.
I'm sorry,
well.
which one are you doing next?
Number 50.
Number 50. Okay, so this is really similar. You're going to square root both sides. So it's what do you get on the right hand side when you square root?
We square plus or minus 7.
Okay, so 2 plus x equals plus or minus 7. This time you can just move the 2 over. So it's positive 7 minus 2, or it's minus 7 minus 2. You want to capture it.
So I got 5 and plus and negative 9.
Yeah.
All right. Next, I want to go through 61 through 65. Evaluate the discriminant and use it to determine the number of real solutions of the equation. If the equation does not have real solutions, tell whether they are rational or irrational. Do not actually solve the equation.
So this is like a test question where they tell you don't do the work, just do part of the work. You know, part of the work being the discriminant here. Do you want to look at all of them or just one in particular one, or maybe the evens? You don't have them.
For the homework, it just wants me to go through 61 through 65.
Okay. We're coming down to the end here, so let's start with the evens. 62 first. 8x squared equals 14x minus 3. You still want to get everything on one side for this to work. So this is 8x squared minus 14x plus 3 equals 0. And it's just asking for the discriminant. The discriminant is b squared minus 4ac. So this is the minus 14 squared minus 4 times 8 times 3. And there's really three things that you care about. You care about whether it's positive, whether it's 0, or whether it's negative.
Okay.
So this one is positive. Go ahead and confirm the value, but it is positive.
All right. This one is negative 14 squared minus, all right, 4 times 8 times 3. Oh, it's just 100. It's positive.
Positive, great. When it's positive, this is like a table here. When it's positive, it has two real solutions. Okay. Now, rational or irrational depends on whether the discriminant is a perfect square. So since it's 100, the square root of 100 is a perfect square, which means that it is rational.
Okay.
Because
So it's right.
yeah, so if the discriminant is a perfect square, that's how you know whether it's rational or irrational. So let me try to draw a diagram here. If it's positive, it could be a perfect square or not a perfect square, and this is when it's rational.
Mm-hmm.
This is when it's irrational. You could have the discriminant could be 0, and then it's always rational. And then there's when it's negative, and it's always, this is always complex valued. So this rational irrational business only really applies to whether it's positive or not.
All right. And so it's irrational whenever it's when it's not a perfect square.
Yeah.
Okay, that makes sense.
So you're looking for things that like, but you gotta be careful. Like, oh, you might misremember. That I don't know, 441 is a perfect square. It can happen. So let's look at 64. 64 here. It says 2x squared minus 4x plus 1 equals 0. The discriminant is minus 4 squared minus 4 times 2 times 1. That is 8. 8 is not a perfect square.
So it's irrational.
That's right. It's real, but irrational, if that means something to someone. All right, let's do a 66 to close out here. I want to get everything on one side of the equation. 3x squared equals 4x minus 5. So move the 4x over, remove the 5 over. So now the b squared minus 4ac.
This one's negative, so it'll be irrational.
It'll be complex valued. Right,
Oh.
it's minus 4 squared minus 4 times 3 times 5, which ends up being this is negatives. This is whatever. This is complex valued. All right, I'm going to send this off as a PDF, and then I'll also send you a link to the video as soon as it's done uploading. Apologize if there's been some delay in that, but I'll get to it as soon as I can. Thanks so much, Jack, and appreciate you booking with me today, and be happy to help you again next time.
I appreciate your time. Thank you very much. I
You're welcome.
appreciate your
See you later.